So welcome friends. I am today going to talk to you about a concept of p-value in hypothesis testing. Now, most researchers, students find the concept of p-value a trifle confusing, but let me explain to you that the p-value in hypothesis testing is the best form of knowing whether your null hypothesis is rejected or your null hypothesis is not rejected. In the earlier videos, what we have seen is we have performed a z-test, and when we performed the z-test, the level of significance gave us the critical values. We then went ahead and calculated the value of the z statistic, compared the value of the z statistic with the critical values, and then came to a decision on whether we should reject or not reject the null hypothesis. So to summarize, what did we do? Let me take you to a small PPT and let me explain to you what is it that we exactly did. We said alpha is 5%. Now this alpha gave us our Z critical, or what we call the table value of Z. It gave us the Z critical, and then this Z critical we compared with Z calculated. Now the p-value approach is the opposite. What we are going to do is we are not going to find Z critical, but this calculated value of Z is going to give me the p-value, and this p-value we are then going to compare with alpha. So I repeat what we have done so far. Given the value of alpha, we found out the Z critical, and the Z critical was compared with Z calculated, but we are going to take the opposite route and we are going to find the Z calculated, and this Z calculated will be converted into the p-value. Remember, p-value like alpha is the area, and therefore this p-value is compared with alpha to draw some inferences. Now what is this inference that I am talking about? If the p-value is greater than alpha, do not reject HO. But if the p-value is less than or equal to alpha, I am going to say reject HO. So how do I use the p-value approach? The p-value, if given, you compare it with the level of significance alpha. If the p-value is greater than alpha, you do not reject the null hypothesis. But if the p-value is less than or equal to alpha, you are going to reject the null hypothesis. So now, how do I calculate the p-value? Let us suppose the Z calculated value has come minus 2.5. Okay, then the area from this point to minus infinity, I repeat, area from minus 2.5 Z value to minus infinity is known as the p-value. So how do I calculate the p-value? I go to the Z table, find the area corresponding to Z is equal to minus 2.5, and if at all this area is given from the center line, as in most cases, subtract the value from 0.5. But however, if your table gives you the area from minus 2.5 to the minus infinity part, then that is going to be your p-value. So the p-value then gets compared with your alpha, and once again on the basis of how it compares with alpha, you are going to decide whether to reject or to not reject the null hypothesis. Now this is true for a one-tail test. A one-tail test can be a left tail as you see in the screen, or it can be a right tail, in which case the area would be calculated from the Z value to the positive infinity. So just keep this factor in mind, that whenever we are going to have the p-value either on the left hand side or on the right hand side, it is an area, so it will always be positive. If the calculated value of z statistic or t statistic happens to be negative, then from that point to minus infinity. If the calculated value of z statistic or t statistic happens to be positive, then the area from that point to plus infinity. Now, what is going to happen if at all we are going to have a two-tailed test? Now, this is going to be, in case of two-tailed test, the area in the left tail is alpha by 2, the area in the right tail is alpha by 2, and depending upon what is your calculated value of the statistic, either z or t, you are going to find the p-value. So let us say for some reason that this is my p-value. And in case of two tails, the p-value has to be compared with alpha by 2, because on the right hand side we have alpha by 2, on the left hand side we have alpha by 2. So what we are going to do is, in case of a two-tailed test, we are going to multiply by 2 on both the sides, and ultimately we are going to compare 2p with alpha in case of two tails. Whereas in case of one tail, it is the p that will be compared with alpha. So this is something that you will have to keep in mind. If it is a two-tailed test, you will have to calculate the value of p as always, but the value that you so get has to be multiplied by 2. And this is how we are going to use the p-value for our analysis. Now, what are going to be some of the advantages of the p-value? There are multiple advantages of the p-value. One, obviously, as you have seen, it helps you to decide whether to reject or not to reject the null hypothesis. But very important is that whenever you are going to reject a null hypothesis, you need to be fairly confident to reject. I repeat, whenever you are going to reject a null hypothesis, you need to be fairly confident to reject. The p-value is used for rejection, and it is little less than 0.10. I have got little evidence or some evidence that the null hypothesis is not true. If the p-value is less than or equal to 0.05, my evidence becomes little stronger. So I have a little stronger evidence that HO is not true. But if the p-value is less than 0.01, I have a very strong evidence that the null hypothesis is not true. And likewise, if the p-value calculated happens to be less than 0.001, then I have an extremely strong evidence that HO is not true. Just to give you a rough analogy, let us say a student is appearing for an exam and 100 marks paper, 50 marks is passing. And the student has got 48 marks. And because he has got 48 marks, which is less than 50 marks, he is decided to have failed the test. Now the question is, when a faculty is allocating 48 marks, how sure we are that the student deserves 48 and not 50 and above? There could be a totaling mistake. There could be a question which was not checked. There could be some harsh assessment. And because of this, whenever we are going to fail a student, since he has got 48 less than 50, there is a doubt in our mind. But supposing the same student has got only 15 marks, 1-5, where the passing is 50, there is no doubt in our mind that the student should have failed, because even if there is an assessment error, the 15 cannot go beyond 50. And therefore, the same analogy, the same application is for p-value. If at all the p-value that you have calculated is less than or equal to 0.001, there is no chance of making a mistake. There is no chance that you are wrongly rejecting the null hypothesis. But supposing your p-value is hovering near 0.05 and you are deciding to reject the null hypothesis, then my friends, there is a possibility that you are rejecting a null hypothesis wrongly. Maybe this is a scenario where you might want to do a retest. So this is the second advantage of p-value. It gives you the strength of rejection. We don't need a strength to not reject. That's fine. A student gets 51 marks out of 100. We are not going to bat an eyelid. But if a student fails because of 48 marks out of 50, then this is going to be the source of concern. The third advantage of the p-value, if at all you are doing a z statistic, you need to have a z table. If at all you are doing a t statistic, you need to have a t table. But supposing the software is calculating the p-value and giving it to you, you are not really concerned what test has been performed, so long as you are given the p-value to compare with alpha. And therefore, this is the third advantage of the p-value. You need not know, you need not have the various tables, but p-value provided, compare it with alpha, and you can quickly want to end the session of discussion on p-value, and I'm quite sure you would have gained some knowledge in this area. Thank you very much.